Hello, this is Nitin Dahad with EE Times from the Global Semiconductor Conference in Malta. I'm talking now to Alissa Fitzgerald, the founder and CEO of AM Fitzgerald. Alissa, hello.
Hello, how are you today?
Did I get your name right?
You did.
Okay. So, Alissa, tell me a little bit about your background. I'm sure our viewers would want to know.
Yeah, certainly. So, actually, I started my career as an aerospace engineer and worked in that industry for a while. But then when I was at graduate school at Stanford in the it was late 1990s, discovered MEMS and ended up doing my thesis research in that area. And now 30 years later, here I still am, deep inside the MEMS industry.
And in those 30 years, so you've been involved in the industry? I mean, what kind of things
right.
have you been involved with?
Yeah, so before I started my own company, I worked for a small MEMS startup. It was a spin out from Stanford, and they were trying to commercialize a MEMS ultrasound transducer for medical imaging.
Right.
So I worked for that company for several years, and then founded my firm, AM Fitzgerald and Associates, in 2003. We are now 21 years old. We're a MEMS product development firm serving companies worldwide, and we're helping uplift technologies from TRL 3 or 4 and help customers commercialize these emerging technologies and get them into foundries for mass production.
Any examples you can talk about that we can just get a flavor?
Yeah, certainly. MEMS technology is very broad. It has many end-use applications. We've worked on everything. I won't name names, but we've worked on tiny electrostatic actuators for tunable laser devices. We've worked on both pressure and ultrasound sensors for medical devices. We've worked on chip-scale atomic clocks. We've worked on the precursors of some quantum computers, infrared technology. So it's quite a long list.
Okay.
Even genomic chips, microfluidic genomic
Interesting,
chips.
interesting. I mean, that sort of leads to the next question, which is, MEMS has been around for a long time, but it's actually contributing, or it's the foundation for a lot of what we talk about today in advanced packaging,
That's right.
chiplets, 3D integration and all that. So tell me some of your thoughts on that and where it's going.
Yeah, that's right. So MEMS, for the audience who doesn't know, it stands for micro electromechanical systems. So there's a fair amount of mechanical engineering in what we do. And so MEMS technologists, we've been drilling down into silicon wafers for decades. We've been stacking wafers together to make our various micro sensors and micro actuators. And part of that innovation we have been finding in sort of micro mechanical engineering has been leaking over into the semiconductor industry. And we've seen this really interesting progression from making micromechanical devices to now some of that technology finding its way into advanced packaging, 3D IC. The through silicon via is a great example of crossover technology.
And what are the challenges you're seeing in getting some of those technologies deployed in maybe some of the projects you're doing?
Yeah, well, like all tiny electromechanical devices, there's a strong interaction between design and process. They're really, inseparable, which is very different. You end up with situations where you have thermal issues, stress strain issues, warpage issues on the wafer or the chip. And so one thing I think we're seeing already with 3D IC and integrated packaging is the semiconductor folks are starting to realize they have to deal with these bothersome mechanical effects like warpage, like stress, cracking, things like that heretofore you hadn't had to deal with in a monolithic IC. So they're starting to experience the kind of reliability challenges, durability challenges that Thermal, exactly, that MEMS people have been trying to resolve.
So a lot of the EDA tools companies, EDA companies are telling us, we've got all the tools that can allow you to simulate all of this. I mean, is that an answer, or is there more to it than that?
Well, I think there's more to it than that. And so Synopsys, of course, recently bought ANSYS.
Correct.
ANSYS is a 40 to 50-year-old finite element solver that all mechanical engineers use when they're building anything from a jet engine to a MEMS device. Yeah. And so I think the fact that Synopsys purchased ANSYS indicates how important this type of mechanical modeling and analysis is to the semiconductor industry right now.
And you've got Siemens and Cadence trying to do all the,
course,
the FEA and all that.
That's right, and of course Cadence, Siemens, et cetera, they're all working on it as well. But I thought the acquisition of ANSYS was really
significant. Okay, on innovation, your panel that you were involved with at the conference here was talking about open access fabs for sort of trying to spark innovation. Tell me a little bit about that.
Yeah, so we had a great panel yesterday, and part of the theme was how does one, we're here in Malta, how does one promote innovation and spark innovation? We said a la Silicon Valley, we're not here to clone Silicon Valley, but
Yeah.
to draw on some inspiration from the innovation activity in Silicon Valley. And one comment that I made on the panel is that having access, you can't invent semiconductor devices in your kitchen. You can't do it in your garage. You need access. If you're a device innovator, you need access to a fab. And I think one thing that's been wonderful in Silicon Valley is we've had access to the chip fabs at Stanford, at UC Berkeley, and our company sends its own fab team in to innovate MEMS devices, but there are dozens of other innovators doing the same thing. So my suggestion on the panel yesterday and to the industry groups here who are trying to promote innovation in Malta is to develop some kind of open innovation facility here so that entrepreneurs and innovators here can use the tools to create these new devices.
Are there signs of that happening?
Well, I've come to understand University of Malta does have some equipment, but it sounds like they need to boost their capabilities here and add more tools.
So part of that will be from the investment I guess for setting up in Malta as well, the silicon
imagine.
catalyst. Okay.
Yeah.
What was your key takeaway from the conference?
Well, our industry is really thriving. It's still quite a global industry. I think right now with semiconductors, there's a lot of nationalistic forces to try to pull more of the supply chain inside one's own domestic borders. But this meeting for me reaffirmed, as we saw people from all over the world here, that it's still very much a global business, and we need a free exchange of ideas to help the whole industry move forward. And what I saw here in Malta is definitely a spirit of entrepreneurship and openness, and I think we've got ripe initial conditions here to promote the industry in Malta as well. And of course their long history with packaging at their ST plant, I think identifies packaging, which is very key to any commercial product success. They've got a center of excellence here.
Well, packaging is key at the moment. So
yes.
Alissa, thank you very much.
Thank you. You're very welcome.
Thank you.
Nice.